Okay, so this is one of my favorite slides because like when you're a nerd like me, you have favorite slides. So this slide is going to show you how we make a chain of amino acids, and it's super clear. I really like it. So first of all, what do we got here? Here is an amino acid. How do we know? Well, we should recognize the central carbon, the amino group, carboxyl group, the H, and the side chain. So on this diagram, this is the side chain. Okay, and here is another amino acid side by side with it. Again, central carbon, amino, carboxyl, H, and a side chain. Now, the first question for you is, are these two different amino acids? And you should be able to look at it and immediately say yes, because this side chain is not the same as this side chain. So this is two separate amino acids, and they're separate. There's nothing connecting them yet, right? There's no line between them. There's white space. So these are two separate amino acids. So we're going to put them side by side, and then the chemical reaction is going to happen. So here's my arrow showing you this is what we're starting with. So these are my reactants up here. And here's my product down the bottom. All right, we're making this thing here. And here's another part of the reaction. All right, so what we're doing here is we're taking an O and an H from this amino acid on the left, and we're taking an H from this amino acid on the right, and we're creating H2O. And if we pull that out, we can then hook that C directly to that N. And you can see here, here's the C hooked directly to the N. All right, so this is something that should be familiar to you, what we just did there. I'm going to show you it again on this one. We're going to go down the line. Here's amino acid. Here's its carboxyl group. Here's another amino acid. Here's its amino group with an H. We've got an OH and an H, so two H's and an O. We can put them together and create H2O. And then we can hook that C directly to that N instead. There's that hooking directly. So this should look familiar. This is, I'm going to write it down. Hopefully you can think of it before I finish writing it. Condensation synthesis, right? Synthesis because we're building something bigger by hooking things together. And what we're building is this long chain here. And condensation because water is appearing. Water is being pulled out. Water is appearing here. So this is how we build proteins. We take individual amino acids and we join them up in a chain using this condensation synthesis reaction. This is something that we've learned before. This is just how we build chains in biology. It's how we hook together glucoses to make starch and glycogen, right? It was how we hooked the fatty acid tails onto the glycerol. Now we're using the same reaction to hook amino acids together. So it's a really useful reaction to remember. You only have to remember one reaction, condensation synthesis. Doesn't matter what you can hook together many different things and build different things just with the same kind of reaction. So here we're hooking together amino acids to build a chain called a protein. All right, so when you do that, you can see here's my chain growing. Here's like my first bead in my chain. Here's my next bead. Here's my next bead. Here's my next bead. If we go back to my metaphor from earlier. And you can also see that each bead has its own like separate side chain poking off of it. Right? They're all a little different. So one of the ways we think about this is we think about proteins as being a backbone built of this, the backbone, and then there are these side chains that sprout off of it, kind of like the teeth coming off of a comb. And now you can maybe start to understand why it's important to know about the side chains and know whether they're hydrophilic or hydrophobic. They are really important. Like this one here, it's got an OH, so that's a hydrophilic side chain. This doesn't have any O's or N's in it, so this is a hydrophobic side chain. Here's a hydrophilic side chain. All right, so we'll get more into that in a bit. The other thing that's important on this slide is this structure here that I'm squaring up. All right, so between one amino acid and the next, once you've done the condensation synthesis and you've joined them together, you get this thing here, which is called the peptide bond. Now, it has a special name, but it's not special in that it's just a covalent bond. It's like any other covalent bond. This C and this N are sharing a pair of electrons, and that's how they're bonded together. But you get this other stuff around here. The C has a double bond to an O. That's like what's left over from that carboxyl group. And this N has a bond to an H, which is what's left over from the amino group. So this structure, which I'll draw out here, C to N, which happens between two amino acids in a chain. The C has a double bond to an O, and the N has an H. This whole thing is kind of like a special arrangement of atoms in this way that you only get in proteins. And so the peptide bond is this specific bond right here. This is the peptide bond. But then all this other arrangement of atoms does something kind of special. So I'm going to flip onto a blank screen here. I'm going to draw out a peptide bond. So C, N, H. Okay. Now remember, there's other stuff going on this way, all kinds of other chain stuff, and that this goes on this way. So there's stuff going on here and there's stuff going on here. But right now, I'm just focusing on this. Oh, sorry, that was a mess. Right now, I'm just going to focus on this part of the chain, which is the peptide bond that's happening between the two amino acids. And when this happens, because of the fact that the O right down here and this N right here are very electronegative. Remember, those are some of the most electronegative atoms that like to suck electrons towards themselves. Electrons get kind of sucked all the way down to the kind of bottom part of this bond, and this ends up being a little bit negative, and this ends up being, it's poor hydrogens. Hydrogens always lose out in these situations. This hydrogen ends up being a little bit positive. So if I take out all my junk here, didn't mean to lose the O. Let's put that back. All right. So in a peptide bond, like the structure I've drawn here, you always get a slightly positive, slightly negative charge on the oxygen and a slightly positive charge on the hydrogen. That's a really important thing to remember. You get it on every single peptide bond. So if I go back to this slide and clean up my mess here, I'm going to draw on here. This is going to be slightly negative, this O, and this H is going to be slightly positive. And here's another peptide bond. So this is going to be slightly negative, and this is going to be slightly positive. And another one, slightly negative, slightly positive, between every single amino acid in the chain. Now this is a very short chain. It's only 4 amino acids long. In real life, proteins are anything from 20 to 200 to 2,000 amino acids long. And between every single one in the chain, you get this peptide bond structure with the partial charges at the top and the bottom. So there's a lot going on. There's a lot going on in this slide, but I hope that explains some of the features to you. This is how we string together amino acids to build a protein.